Okay, so yesterday we had talked about how to solve a system with three variables. Now what they're going to do is they're going to give you points that they want us to find the equation for that would create the quadratic. So when we were looking at the system of three yesterday, when we were talking about what that means, you're in a three-dimensional space when you're graphing something with three variables. What we're doing here is we're looking at 3 points and we're trying to find the function that they came from. Okay, so we're looking for the quadratic function where this would come from. Again, you would have done this last year in Algebra 2. You were given points, and then you had to find basically your coefficients, your A, B, and C, so that you could plug it into this form up here. Remember, this is the general form of our quadratic. Ax squared plus bx plus c. Where a, b, and c just represent coefficients or just numbers. So we're just trying to figure out what is a, b, and c so that we can plug it in and write an equation. To do this, we're going to still use a little bit of what we did yesterday with elimination, with our system of three variables. Again, we're just solving for a, b, and c today instead of thinking about it as x, y, and z and looking for that point where all those lines intersect. So my first example here, I've got the points 1, 4, 2, 1, and 3, 4. And I'm still thinking about this form, y equals ax squared plus bx plus c. Now, all these coordinates that they are giving you have an x and they have a y. So when we're writing these out, we're going to put x and y in, kind of like what we were doing when we were checking if a solution satisfied a system, like we even just did on our bell ringer. But we're not going to be able to put anything in for a, b, and c. Those are going to be the coefficients that we're trying to solve for, so they're going to be our variables for this problem. So they're showing you on this first one where they start with 1, 4. They put 4 in for the y. Okay, this is your y equals your a times the x squared, and the x is a 1, so that's why they put 1 squared in there, plus the b x. They just wrote it backwards. They put 1 in for x and then the b, and they just switched the order. They put the coefficient in the front, and then plus your c. You won't have anything to put in for c because c isn't going to have an x attached to it like the a and the b do. So then what they did is they just kind of cleaned this up a little bit. So we had 4, that comes down. 1 squared is just 1, so that goes in front of the a. The 1 goes in front of the b, which we could just write that as b, and then plus c. So this equation looks like 4 equals a plus b plus c. Now we're going to do the same thing with the other two coordinates. So for this next one, 2, 1, we're going to plug this in the same way. This time my y is the 1. Remember, all your coordinates are written as x comma y. So 1 goes first. Then it's going to be a times x squared. My x is going to be replaced with a 2 from the coordinate. Plus b times the 2 plus c. So all I'm doing is plugging in my 2 for my x's and my 1 for my y. And then I'm going to just clean this up a little bit. So this would now say 1 equals 4a plus 2b plus c. We have to do this for one more coordinate. We have to do it for the 3, 4 coordinate. They haven't written that one down here for us. So we're going to do the same process now for 3, 4. What would that look like if I plug it in initially?
3 equals.
I'm careful. 4 equals, because it's the y first. Yeah. If you're able to compute that mentally, you don't even have to show me the step where you're manually plugging it in and writing squared. You can just start plugging it in, squaring it, writing it out, simplified. So these 3 equations, this one here, whoops, I crossed that one off a little bit, and this one, these are what we're going to use to solve our system of equations. Okay, so we're going to use these to solve. So to do that, we have to think about what we were doing yesterday. I want to get A, B, and C eventually solved for individually, but in order to get started, we have to solve for one of the letters first. And it doesn't really matter which one you do. However, it's probably easiest on all these problems to solve for C, because every time you do a problem like this, C is always just going to be C. There's not going to be a number in front of it. So it's really easy to work with that and make it be whatever you want it to be. The other thing is maybe take one of them right now, just initially, and let's make it negative, because then we can pair it up with the other two and eliminate it really quickly. Now, when I look at these three equations, I think it's going to be maybe best to just make that first one all negative. So I'm going to take this top equation here times a -1, and I'm going to rewrite that as -4 equals -a minus b minus c. So I'm going to use that one, and I'm going to pair it up with the other two separately so that we can do our elimination. So I'm going to bring that down below here. So I'm going to start by writing that -4 equals -a minus b minus c. I'm going to use this twice, so I'm going to write it down 2 times down here. And then I'm going to take those other two equations that I boxed up in yellow, and I'm going to bring them down and put them underneath. So I'm going to put the 1 equals 4a plus 2b plus c underneath that first one. And then I'm going to bring down my 4 equals 9a plus 3b plus c underneath this one. Everyone following me so far? Okay. Now, the reason why I'm doing this is because my c's are opposite signs. They already had the same coefficient, so I don't have to worry about multiplying by a number or anything like that. I'm just going to add my equations now, and I'm going to solve for whatever's left. So my c's should cancel on both sides. What am I left with on the first pairing? Good. And what am I left with on the second set? Okay. Now we're down to a system with 2 variables. Again, I like to use elimination. I just feel like it's faster than substitution, so I'm going to continue along that route. If you want to use substitution, it's your free will to do that, okay? I want to get these to look something the same. I think it's going to be easier to get our b's to match, and I want them to be opposites. So what should I take this equation times to get that to happen? -2. And I'm just going to write that underneath this one over here if you guys are okay with that, instead of having to write them out both. I'm going to rewrite this now as 6 equals -6a minus 2b. Okay, if I add these, what am I left with?
Oh, wait, never mind.
It's all right.
6 and 2.
So 6 equals 2a, so a would be 3. You found 1. Now we need to go back and find b and c. So we start going back to our other equations. So I'm going to take a, I'm going to plug it back in. Where would you guys like me to take it? The one above it, the 0 equals 8a plus 2b. So that would be 8 times 3 plus 2b. There's a 0 over here. So this would be 24. You would end up subtracting that from the 0. So that's a -24 equals 2b. What's b going to come out as? -12. Okay, and then what should we do to find c? Yeah, so coming all the way back up here, I'm going to zoom out. I know it gets kind of small, but you take these both and we go way back to the beginning. I don't care which one we go into. I might just do the 4 equals a plus b plus c because that's the simplest one. So 4 equals 3 plus -12 plus c. What's c going to come out as? 13. Okay, now we're not writing our answer for these problems as an ordered triple because they don't want that. That's not what this is showing me. Those points that they started me with are points that are all on this quadratic function. So I need to finish this by writing out the quadratic function. So the quadratic is going to say y equals, then you put the 3 in for the a, so 3x squared. The 12, negative 12 goes in for b, so minus 12x plus 13. That's what they have written down here at the very bottom of your page. That's where the a, the b, and the c all go, is they get put in for those a, b, and c that we had on that equation. Again, we're thinking about this form again. So instead of finding an order triple that would satisfy the system of equations, we're looking for the equation that those coordinates came from. Now this would be a parabola, so that's why those points kind of are the way they are, because remember, parabolas are those U-shaped graphs, so they're going to have a lot of points on them. Okay, let's go ahead and do one more of these together. I'm going to have you guys kind of help me walk through this a little bit though. So let's start first by just writing out our equation. So if we start with the 146, and again, you're thinking about this equation right now. What would that say if you plug it in? What goes in for the y? 46. What are we putting in for the x's? Ones. So it would be a times 1 squared, which is just a. B times 1, which is just b, plus c. Okay, then we do the same thing for 2 and 84, and for 3 and the 114. What are these going to say? Mm-hmm. 4a, right? Good, plus c. And then the last one? Good. I just skipped over the step where I plugged them in individually and squared those numbers that I could. I just went ahead and wrote it. Again, I'm going to maybe take the top one times the negative. Take it times a negative 1 to make that c become negative here. So this would be negative 46 equals negative a minus b minus c. And then we're going to start pairing those up with our two equations. Okay, if we add those together, what are we left with on the first, like on my pairing up here on the left-hand side?
Plus
1b, so b? No c. Okay, how about on the other side here? 68 equals what? Good. Okay, what would you guys like to do next? Okay, so that would now say negative 76 equals negative 6a minus 2b. Oops. If I add these together, what am I left with?
negative 8, 2a, and that's it.
So A is -4. Okay. Now we start going back. So if I take -4, I'm going to plug it in over here just because these numbers are a little bit smaller. So 38 equals 3 times -4 plus B. What happens there? It'd be 38 plus 12.
Negative 12. Wait.
Yep, it would be -12, but then we'd add it over, right?
So
50. And then if I go back to the beginning, if I do 46 equals -4 plus 50 plus my C, what do we get for C? It's 0. So let's write our equation. Remember, it's y equals ax squared. So what are we putting in for a? So -4x squared. What goes in for b? 50. So plus 50x. And there is no c. You don't have to write plus 0. We can just leave it here. Just like yesterday, it's very easy to make a mistake if you miss a negative sign or you add something incorrectly. So these are not the kind of problems that you want to try to go really fast through or try to get done quickly. You want to take your time, be tedious about looking for those signs and all that stuff. Okay.